Hi everyone, welcome back to Codera. Today is the seventh session of Mastering Game Theory, CodeForces problems. So just let me know in the comments if I am audible and my screen is perfectly visible to everyone or not. And then after that, we'll start with the session within some minutes. Just quickly let me know if my voice is audible to everyone and there is no issue with my screen as well. And then we'll start after this. Today we are discussing uh, three problems again. First of all, we'll be completing the code for this problem, that is even odd game, that we were discussing yesterday. After that, what we'll be doing is we'll be covering this problem, that is Palindrome Game, and then after this we'll cover this problem, that is Little Girl and Game. Okay, this is what we'll be doing. So if you have joined the stream, so please consider giving a +1 in the chat and please like the video if you haven't already, so that we can start this session as soon as possible. I'll just wait for some time for everyone else to join in and then immediately we'll begin ahead with the problems. So today the level of problems will go a little bit higher. We'll also be discussing the problems which are rated something close to 1300, so that we can learn more about how to approach such problems and what should be the thought process for solving such problems. Okay, so meanwhile everyone else is joining, I'll just wait for just 2 minutes more for others to join and then we'll begin ahead with today's session. So if everyone who has joined said, they can just consider giving a +1 in the chat. Right, so we'll first of all be completing this problem, that is game, that is this game that is even odd game. We will be writing the code for this problem. So what I told you yesterday about this problem was that in this problem we just simply had to check, right? We just simply had to do it in basic manner. What we'll be basically doing is, in this problem what we'll be basically doing is, we'll just be checking that part, right? We'll just be taking the inputs and after that right away we just need to do it in a similar fashion, right? So what will be given is, we will be given test cases and will be given n. Okay, so let us do this. Let us do for this problem. What I'll be doing for this problem is, first of all I'll be declaring long n comma I, and then I'll be having, let's say, score 1, let's say s1, that is score 1 for Alice and score 2 for Bob. And apart from this I don't think that I will need anything else. I'll take the array as an input for this problem, and once I have the size as an input, I'll simply, once I have this as an input, I'll simply take the array as an input, right? A of n. So let us input the array for the first problem. What I'll be doing is, I'll be doing I is less than n, I plus plus. Once we have done that, so we'll take every element of the array ai as an input, which will be giving the score piles that we have, or the element of the array. After that I'll sort them according to the decreasing order. Why? Because I basically need them to be sorted in decreasing order, because all of them, both Alice and Bob, will be trying to pick the maximum possible, right? All of you who have joined, just quickly comment down +1. Okay, just quickly comment down +1 so that we can begin, we can keep on continuing. Basically we are coding the problem, that is this problem. The problem name is even odd game. We are just trying to code out this problem. We had discussed this problem yesterday, only the code part for this problem was left, so that is something that I will be doing quickly. Okay, so what I'll be doing is, I will be starting from 0, I is less than n, and I plus plus. Since first of all Alice will be picking, right? So I'll check if I mod 2 equal 0, that is if it is even, then the chance will be for Alice. And if a of I, if my a of I mod 2 equal 0, that is if it is even then Alice will be picking, right? So s1 plus is equal to what? AI. That is simply what I'll be doing. The score 1 will be what? The score of Alice, right? That is what I'll be having. And in the else part, if the I value is odd, then in that case what will I do? I'll simply do one thing, and that is that if my a of I mod 2 equal 1, then in that case my score 2 plus is equal to what? A of I, because I'll be adding that particular score, right? And since this much part is done, what will I do in the end? I'll check. What will I check? If s1 is greater than s2. If that is the case, there will be 3 cases, right? So let me see how the output format looks like. So if s1, if the player 1 is score is greater than player 2, then I'll simply do what? I'll print Alice, and I'll do an endel. Else if s2 is greater than s1, then what I'll do? I'll print Bob, because Bob will be winning in that case, right? And in the end, all those who have joined, they can just consider giving a +1 in the chat, or they can like the video. Okay, right? And if both are equal, so in that case I'll print a tie. That is what I need to do simply, right? This is the code that we are discussing, that we had to discuss yesterday, but since we were out of time, so we couldn't. So if anyone has any doubt, they can ask in the comments. So let me see. Bob, tie, Alice. Let's see what we get output. Bob, tie, Alice, right? We are getting this output. Let me just copy this and see whether our code works or not. So I'm trying to submit my problem now. Let's see whether it works or not. Okay. So yeah, I've just submitted this problem. Let's see if it gets an accepted or not. So you can see that the problem got accepted, right? So this was an easy problem. We had discussed about its concept yesterday in the session 6. So if you haven't watched that video, you can just consider watching that video. Today we just had to code that problem, because what you'll be doing in this problem is, in this problem you will just be starting and you will be taking all the inputs, then you need to sort in the decreasing order. After that, if it is even, then chance will be for Alice. And if the element is also even, then in that case you will be doing s1 plus is equal to A of I. Else if the number is if the index is odd, so that simply means that the chance will be for Bob. And if the number is also odd, then in that case you will be adding it for Bob. And simply in the end, if s1 is greater than s2, then that means Alice wins, otherwise Bob wins. And otherwise, in the else chance, who will win? In the else part, simply you'll say that there is a tie, right? This was the problem. Just quickly tell me in the comments if that much part is clear to everyone or not, and after that immediately we'll begin ahead with the other problem as well, right? Is this much part clear to everyone? Just quickly let me know in the chat if this much part is clear to everyone. Is it clear to everyone? Just quickly let me know in the chat. Only then we can consider moving ahead. I'll just be waiting for your replies in the meantime. Perfect. Now let us see the next question. The next question that we are having is what? Let's take this question as the next question for us, and we'll be looking into this question. You can just consider writing anything in the chat that you don't understand, and I'll be explaining it to all of you again. Okay, so let us move ahead with this problem and see what it has to say. So the problem name is Palindrome Game, right? Problem name is Palindrome Game, and this is an easy version of this problem. So the only difference, like we do not have to read this first line. So you have been given a palindrome is a string. A palindrome is a string which reads from the left to right and right to left, right? So that is what has been given. So what basically does a palindrome mean? So let's say if I talk about this string, that is 1 1 0 0 1 1. So this is a palindrome, right? Why this is a palindrome? This is a palindrome simply because this element is equal to this element, right? the first element is the first number is equal to the first character is equal to the last character, the second character is equal to the second last character, and the third character is equal to the third last character, right? So that is why this is a palindrome. Now this much part is clear to us. What should we do further? So let's say you have 1100, right? So this is not a palindrome, right? This is not palindrome. Why? Because you can see that it does not read the same from left to right. From left to right, it reads 1100, and from right to left, if you read, so it will read 0011. So since both are not the same, so that is why you will not consider it as a palindrome, right? Now let us move ahead with this problem and see next part. So what does the problem say further? What does the problem say further? So furthermore, the problem says that right, if you in case you have any doubts, so you can mention that in the comments. I'll be looking into your doubts. Okay, a palindrome is a string. This much part is okay. Alice and Bob are playing a game on a string, so they are playing a game on this string, which is initially a palindrome in this version. So they are playing a game on this string s, which is initially the s given to me is palindrome, right? Now what happens next is, if you have just joined, so you can just consider giving a +1. If you want, I can explain the questions from scratch once again. Just quickly comment down +1 if someone has joined recently. Okay, so what I'll be doing is, basically you'll be given a palindrome string, and Alice and Bob are playing a game on this palindrome string, which is of length n, and it is a binary string, so it consists of characters only zeros and ones, and both the players are taking alternate turns. So as usual, Alice is starting and then Bob is going. Okay, hi, that's great. So in each turn, the player can perform one of the following operations, right? So in each turn, what you can do is, a player can perform one of the following operations. What are the operations that a player can perform? Sorry sir, today I am not able, right now I am somewhere outside, urgent work. We'll see this session today night, and thank you for your effort. No problem, no problem. You will get the recording, so you can watch that out. And in any case, if you have any doubts, Seti, you can feel free to ask in the comments. I'll be looking into the comments. You can ask them in the comments, right? What we'll be doing further is, Alice and Bob, they are playing this game, and they are changing the turns alternatively. So in each turn, the player can perform one of the following operations, right? So in each turn, the player can perform one of the following operations. Either he can choose any I where si is equal to 0. Either he can choose any I where the value of si is 0 and change this si to 1. Okay, either he can choose any I, right, any index, and where si is 0 and change it to 1, and he has to pay $1 for that. Okay, he has to pay $1 for that. Or he can reverse the whole string by paying $0. Basically not have to pay any dollars, and he'll just reverse the string. This operation is not is only allowed this operation is only allowed if the string is currently not palindrome. You can only apply this operation if the string is not palindrome and the last operation was not reverse. Okay, in the last operation, if you did not reverse it, and if the current operation is not like that, so you can do that. Okay, you can just if someone new has joined, so you can just comment down +1 if everything is working fine. Okay, so that is if Alice reverses the string. So if Alice reverses the string, then Bob cannot reverse the string in the next move, and vice versa. Let's suppose that Alice has reversed the string, so in the next move when Bob comes in, so Bob cannot reverse the string, right? And if Bob has reversed the string, considering that the current string that he is reversing, it is not palindrome, so in that case, in the next move, if Bob is reversing, so in the next move Alice cannot reverse it, right? So this is what has been given. Reversing a string. Hi ring gamer, that's great. It's great that you have joined, right? In case if you have any doubt with this problem, I'll be explaining this problem. So in case if you have any doubt, so you can just mention that, right? Okay, perfect. Let us move ahead. So what does reversing a means? Reversing a string means that if it's 0, if it is 0 1 0 0 1, right? If it is 0 1 0 0 1, so if you will reverse it, right, you just reverse it and it becomes 1 0 0 1 0, right? This is what reversing a string means. I can see a lot of new people have joined, so if anyone new has joined, so please give a +1 in the chat. Okay, so the game will end when every character of the string becomes 1. The game ends when every character of the string becomes 1. The player who spends the minimum dollars till this point will win the game. The player who is spending the minimum number of dollars will win this game. And if it is a draw, if it is a draw if both of them are spending the same number of dollars, right? If both players are playing optimally, you have to output. If Bob wins, then you have to print Bob. If Alice wins, then you have to print Alice. If in case there is a tie or a draw, you have to print draw. I can see a lot of new people have joined, so please like the video and please comment down +1 quickly, so that we can begin, we can move ahead with this session. And if you want me to explain the question again, I can do that as well. I'm just waiting for your responses. Just quickly give me your responses. Okay, let's read the problem statement further and see what it has to say. So the problem further says that the player who spends minimum will win, right? So let us have a look at the test cases first and see what they have to say. Okay, right. This is the first test case that we'll be looking into. The first string is of size 4 and it has been given 1 0 0 and 1, right? So shall we begin ahead? Is this much part clear to everyone? If this much part is clear to everyone, then please comment down +1 or clear. If this much part is clear to everyone, if you have any doubt or you have missed the problem statement, you can comment down that I need to explain it again, and I'll do that as well. Is this much part clear to everyone? Just quickly tell me in the comments. Is this much part clear to everyone? Okay, right. So moving on, what will happen in this case is, let's read how they are dealing with the first case. So what they are doing is, in the first move, Alice has to perform first operation, right? Why she has to perform the first operation? You can see that this particular string is palindrome, right? So Alice has to perform this operation, right? So let us see what will happen when Alice will perform this operation. So Alice has to perform this operation, so Alice will be performing this operation and the string will look like 1 1 0 and 1. Let's suppose that she chooses this index and she marks it as 1, right? After this, what will happen? Alice has spent $1 and currently Bob has spent $0, right? After this, you can see that this is not palindrome, right? This particular string is not palindrome. So what will you do? Since you can see that this particular string is not palindrome and Bob comes in, so Bob will Bob will reverse this string now, right? After Bob has reversed this string, what will happen next? Now Alice comes in again and notice that Bob's score is 0 and Alice's score is 1. Now Alice comes in and Alice sees the string and this has been reversed in the previous move, right? So that is why Alice has to change this index and this will become 1 1 1 1. So the string is 1 1 1 1, and you can see that now Alice has spent $2 for changing both the zeros, and Bob did not have to spend any dollar. That is why for this case you will say that Bob wins, right? For this case you will say that Bob wins, right? Now let us have a look at the second test case as well. Let me quickly write the second test case as well for all of you, and let us see what will happen in that case, right? So let us have a look at the second test case. So the second test case is where you have just 0, right? So in this case you can see that Alice comes in and Alice has to change the 0 to 1, right? So Alice's score will be 1 and Bob's score is 0, and now this string has become 1. So that is why if the Alice has spent more dollars, so if Alice has spent more dollars than Bob's, and that means that Bob wins, right? Because Bob is spending lesser number of dollars. Is this much part clear to everyone? Just quickly comment down below if this much part is clear to everyone. Please quickly comment down below. Please quickly comment down below if this much part is clear to everyone. Only then I can consider moving ahead. Is this much part clear to everyone? Is this much part clear to everyone? Just quickly let me know in the chat. I'm waiting for your replies. Okay. Okay, perfect. So it is clear to you, right? Now let us see what we can do with this problem. Okay. Who will be the winner? Let me write some cases and let's check out who will be the winner in those cases, right? Let's say I have a string just tell me, just write in order who will be the winner for all these cases, right? I'll be writing some cases. So let's say it is 1111. Who will be the winner? Just tell me. For a case like this, let's say it is this. Who will be the winner? For a case, let's say like this, who will be the winner? For a case, let's say like this, who will be the winner? And not this, let's say this. And let's say for a case like, who is going to be the winner for this case? Just quickly comment down below who will be the winner for all these cases, because I want you guys to get some intuition about this problem. Only then I'm going to tell my approach for this problem. Okay, just quickly comment down who will be the winner for each case, right? Can you tell me? For this case you can see that Alice will win, right? For this case you can see that Alice wins, right? Because all of them are one, so game will end initially, right? And for this case you can see that since this string is not reverse, so what will happen? First of all, Alice comes in, and Alice, since this string is not palindrome, so Alice will reverse it, and then Bob comes in. Since it is already reversed, so Bob cannot reverse it, so Bob has to change it. So that is why Alice wins for this as well, right? Alice wins because Alice is not spending any dollar, while Bob is spending $1, right? Is this much part clear to everyone? Just quickly tell me, let me know in the chat. Is this part clear to everyone? Okay, right. Perfect. Perfect. Let us move ahead with the cases. So let's say if this is the case, so Alice comes in and Alice reverses this, so this will look like 1 1 0 0 0 and 1. Bob comes in, Bob cannot reverse it, so what will Bob do? Bob will do one thing. Bob will try to place it as a at a position such that it becomes palindrome, right? So Bob will place this one here, right? Bob will place this one here. Now since Alice comes in, so what will Alice do? Alice has to take a move, right? Because this is not palindrome. So Alice comes in and Alice will make it this. Let's say she makes it like this, 1 1 0 and 1 1, right? Now you can see that for this case it is not palindrome, so Bob has to come in and Bob has to spend $1 again. So for this case you can see who will win. Bob wins, right? But even if after having some cases we are not able to define, right, how do you think that the winner can be determined? Can someone tell me in the chat? Can someone in the chat tell me? I will now try to tell you some cases, right? Let me try to tell you some test cases, and then let's try to see what will happen. Okay, let me try to show you some test cases for this problem. So let's say you have 1 1 1 and 0. If this is the case, then who will win? You will say that this is what, this string is what, this string is simply nothing but this string is not reverse, right? So that is why what will happen, Alice can reverse it, right? So this will become like this. So now Bob comes in and Bob has to make it all this one, right? So that is why Alice wins. Alice will win, right? But what happens with this case? Let's say 1 1 0 and 0. For this case you can see that for this problem it is very easy to determine that this can be 1 1. Since this is not palindrome, so Alice comes in and Alice reverses it, right? After that what will happen? Bob comes in, Bob will mark it as 1 0 1 1, right? After that Alice comes in and what will happen? After that what will happen? Let's say you do this again. After this what will happen? Then the chance for Alice comes in, right? And since Alice chance comes in, so what will happen? What will happen in this case? Can someone in the chat tell me? Okay, I will tell you. For this case, what will happen? Now you will say, now for this case what will happen? For this case you can see that it is what, it is not like that, right? So what will happen in this case? Bob will not play this chance, right? Bob, since it has been reversed, so that is why it becomes like this. Now you will say who will take the next move, who takes the next move. So for this you can simply see that now Alice can reverse it, right? Because it is not like that. Now Bob comes in, Bob sees that it is reversed, so you'll say that Bob loses, right? But let me claim one thing. One thing that I want to claim is that Bob will win. Answer depends on what? Answer is somewhere dependent on the number of zeros, right? Everyone will agree to that. I think that everyone will agree to that as well. That the final answer is dependent on the number of zeros. Why it is dependent on the number of zeros? Because you know that answer is dependent on zeros, right? So let me make some space for this. Okay, let's make some space for this and see what will happen next. So what I'll be doing for this one is I'll simply count. Okay, what I want to say is answer is dependent on the number of zeros, right? Why and how? So let me see for that. What will happen in this case is, what will happen, you take that as an input, right? And you count the number of zeros. After that, what if there is only one zero, right? If there is only one zero, so thus what if there is only one zero? Let's say this is the string. Also one more thing, initially the string given to you is palindrome, right? Initially the string given to you is palindrome, right? Initially the string given to you is this. So Alice cannot reverse it, right? So Alice has to change this one. So this becomes 1 1 1 1 and 1, right? After this you can see that Alice has given one chance and Bob has given $0, right? So that is why Bob wins, because Bob spends lesser dollars. Now let me look at some of the other test cases. Okay, because what will happen, like initial string that has been given to you is even, right? Notice that part. The initial string that will be given to you will be not even but palindrome, right? So what will happen, let's say this is the string that has been given to you. There are 3 zeros and there are 3 ones, right? So after this what will happen, Alice has to make the move, right? Alice has to make the move, because since this is palindrome, so Alice has to make the move. So Alice will make a move here. You will say that okay, Alice will make a move here and make this as 1, right? And now it is, since it is palindrome, so Bob has to make a move. Yeah, right, Bob has to make a move for this. So Bob will make a move. But now since this is not palindrome, so you will say that Bob does it, right? So yeah, Bob does it. So Bob has to spend 1 here, right? So that is why Bob spends 2 and Alice spends 1 for this case. Now who wins? Since Bob is spending more, so Alice wins for this case, right? So similarly you can see what you will observe in this question is, if you will try to take the initial string as palindrome and you will try to have some number of zeros in it and some number of ones, so if the count of zeros is even, then Bob will win. Why is that the case? So that is simply because of the reason, that is only because of the reason that with this case you can see, if the number of zeros are odd, right? If the number of zeros are odd, so in that case you can see that Bob will be losing. Why will Bob can be losing? Because if the number of zeros, let's say the number of zero is odd, right? There can be two situations. Either the number of zeros is odd or it is even, right? And in this also, if the number of odd zero is 1, only there is one odd zero, then Bob will win, because Alice makes a move and Bob wins. After that, if there are other cases that the number of zeros are greater than 1, so in all such cases you can observe, like we discussed for this case, 1 1 1 0 0 0 and 1 1 1. So for this case you could see that Bob wins, Bob loses, right? Because he will be making the extra move. And if it is even, then what will happen, every time Bob comes in, so Bob will make the string even, Bob will make the string palindrome, right? Every time Bob will play a chance, so Bob will make the string palindrome. And that is why what will happen in the end is, what will happen, Bob will make the string, both are playing optimally and Bob makes the string palindrome, so Alice has to make the move. So that is why Alice will be spending more compared to Bob, right? So that is what you have to do in this question. So let me just implement the code part for this problem now. Okay, let me just zoom in a little bit, right? So what you will be given for this question is, you will be given a string s, and after that you will be simply taking the string as an input, and you simply can say that long count is equal to 0, Okay, yeah, or you can say that count of zero is equal to 0. After that, what you will be doing is for int I will be starting from 0. I is less than s dot size, that is I will be iterating for the sizes, and I'll do an I plus plus. Then what I'll do is, if my s of I is equal to 0, if my current ith character, if it is equal to 0, so in that case I will be doing a 0 plus plus. That means that I'll be counting the number of zeros, and if my number of zeros is equal to 1, if it is equal to 1, so in that case what I'll be doing, I'll be simply printing that, right, Bob wins, right, Bob wins, right. And in this case there is no chance for any draw. You can try it out yourself. For some cases you will not find any chance for any kind of draw, right. And if that is not the case, so in the else part, what I'll do is, else if if 0 mod 2, if 0 mod 2 equal 1, so if it is odd, then who will win? Alice wins, right, Alice wins. And then you will simply print and change the line, else you will say that Bob wins, because since this is a very optimal problem, so there can be no chance for a draw. Either of them has to spend more compared to the other, because both are not spending at every turn. They can reverse the string, right, that is what is happening. They can reverse the string, or they can skip the chance of paying $1, right. So that is why this is how it would look like. Let me just copy the test cases for this problem and see whether it works or not. Anyone has any doubt up till here? Just let me look at the comments. Anyone is having any type of doubt up till here? I don't think so. Okay, so we are getting Bob and Bob. Okay, Bob should be written in capital, and Alice should, all the things should be written in capital as well. So let me do that part for us. And here also Bob, and here I'll be writing Alice. Let's submit this problem and see whether it works or not. So I have submitted this problem. Now let's see whether it works or not. Okay, I'm getting a wrong answer on the second test case. Let's see where I could be getting an error. Basically, okay, I have to take the size. I have to take long ends as an input as well, right? I have to take the size of the string as an input as well. So that is something that I was missing initially. And C in n, that is the size of the string. Now let me submit this again and see whether it works or not. Definitely it will work now, because I just did not take this size as an input. That is why we were not able to get through it, right. You can see that this problem got accepted, right. Everyone is clear with this problem? Everyone is clear with this problem? Just quickly comment down +1 if everyone is clear with this problem. Is everybody clear with this problem? Is this problem clear to everyone? Just quickly comment down below. Right, this was the problem and this was the code for this problem. You just had to count the number of zeros. If the number of zeros was 1, then Bob will win. If it was odd, then definitely Alice will win. You can try out some cases yourself, right. So Ring Gamer is giving a +1. Okay, great. So let's move to the next problem now and see what the next problem has to say. So the next problem is named as Little Gun and Game, right. Let's make some space for coding the next problem as well. Okay, right. So the next problem is Little Girl and Game. This will be the last problem that we'll be discussing today. Now let us read this problem statement further. So it says that little girl loves problems on game very much. So she loves problem on game very much. And here is one problem for us. If someone new has joined, so they can just consider giving a like to the video. Okay, so what you have to do is two players have got a string s. So basically there are two players and they have got a string s which consists of lowercase letters. They play a game that is described with the below rules. what basically they are doing is the players move in turns. So basically the players are moving alternatively, and in one move the player can remove any letter from the string. So you can remove any letter from the string, any random arbitrary letter from the string, and after that what you have to do is you simply have to do one thing, and that is that you simply the player moves in turn, and if the player before his turn can reorder the letters in the string S so as to get palindrome, this player wins. Okay, so if the player before his turn can before playing, if the current player can reverse, right, if the current players can reorder the string so that he can make it as a palindrome, then this player wins. Palindrome string is one which reads the same from the back as well as from the end, right? That is what you have to do in this question. Now let me show you. So this string a b b and a is a palindrome string. Okay, so ring gamer is giving a +1. Great. So a b b a, right, this string, let me move down. Okay, so again, like we discussed for the reverse part, so for this one also, like this is a b b and a, so this is also what a palindrome, right? This is all palindrome, right? And abc, let's say abc, so this is not a palindrome, right? So for this you will write not palindrome, right? Okay, now let us move ahead with the further problem statement. So the first player who is not able to make who can make the string as palindrome, the given string as palindrome. So if this is a string abc, then you can never make it as a palindrome, right? But which are the strings that you can make a palindrome? Let us have a look at the test cases so that we can determine how you will say that, right? So you have to determine which player win provided that both the players are playing optimally, and one move, first the player one will start and the second player will go on, right? So for this you are not having any test cases, so that is why just let me comment down this test case input part from this problem. Okay, so if the first player wins, then you have to print first. If the second player wins, then you have to print second, right? If it is a b and a, right, if it is given a b and a, so for this you will say that the first, hi Vanchika Kapoor, again irregular student, try to be on time. You can watch the recordings of the further sessions, the timing up till now, okay, the first 40 minutes, so that you do not miss, right? A b and a for this. Okay, so for this the first player will win. Why he will win? So let us read the explanation for this problem. So is there any explanation? No. So basically what you have to do in this problem is I'm explaining it again for those who have joined. So in this problem you will be given a string and you have the players will be moving, right? Both the players will be moving alternatively and the player will be moving in turn. So what will happen? In one chance, either a player can choose any random letter and he can remove it from the string, or what he can do is, if before taking the turn he looks at the if the current player looks at the string, and uh, he can reorder the string such that he can get that particular string as, let's say, palindrome, then in that case he will win, right? So what does this mean? So now let's say what happens is, let's say there is AB and AC, right? If this is the string, if this is AB and AC, let me see if this is a case, ABCA, right? If this is the string that has been given to us, so what will you do? Can the first player make it as palindrome? Can the first player comes in, can he make this string as palindrome? No, he cannot, right? You cannot, right? So what will you do in this case? What will you do in this case? In this case the first player comes in and he has to remove the character, right? Which character will he remove? He will not, like this is what, a b and c, right? What will he do? He will remove this character, let's say, right? The first player will remove this character. Now the second player comes in. Now the second player sees, now first has done his chance, now the second player comes in and he sees that this string cannot be made palindrome, so he removes this character. Now after that what will happen? The first player will come in again the first player comes in, right? The first player will come again, and what will he see? He will observe, he will simply be observing that for this particular string, you can see that it cannot be made palindrome. So the first player removes this. After that, the second player comes in, and second player will remove this, right? Or you can say that when the second player comes in, so you can see that this is a string and this is a palindrome in itself, right? This is a palindrome, so that is why you will say that second wins, right? Is this much part, if this much part is clear to everyone, then quickly comment down +1 in the chat. If this much part is clear to everyone, then please quickly comment down +1 in the chat. Just quickly comment down +1 in the chat if this much part is clear to everyone. Just quickly comment down +1 in the chat if this much part is clear to everyone. Is this much part clear to everyone? Just quickly comment down if this much part is clear to everyone, right? I'm still waiting for your replies. Perfect. I'm looking into. Okay, it is clear to everyone, right? Is it? Yeah, I think it is clear to everyone. Okay. Furthermore, moving ahead, how can we observe how to determine the winner? That is the case, right? For this problem, the task is that how do you determine the winner? So let me make some space for us to work upon. Okay. How to determine the winner? That is the problem. How to determine the winner? Can anyone in the chat suggest me how to determine the winner? Can anyone in the chat? I mean, I'm giving you 1 minute. Just think, how will you determine the winner? I'm giving you 1 minute. Just quickly tell me in the chat. How will you determine the winner? Just quickly tell me in the chat. How will you determine the winner? Can you think of something? Like let's say I give you a string that is, let's say I give you this string A B A and let's say B. B and C. What will happen in this case? Can someone in the chat tell me what will happen in this case? What will happen in this case? What will happen in this case? Can someone in the chat tell me? What will happen in this case? Can someone in the chat tell me? Can someone in the chat tell me if this is the case, who will win? Right. So for this, first of all, you can easily see. Let me just increase the okay. For this, let me just remove it if possible. Let me see if I can remove this part or not. I can, right? Okay. So now I think everything is still visible, right? What will I do in this case? Can someone in the chat tell me? Okay, so right. So what will you do in this case? In this case, you will say, I can see a lot of people are watching. Please like the video if you haven't, so that it can reach as many people as possible. Okay, right. Let us move ahead. So for this problem, you can see that this you have to check the win. When will your win determine? Right? Win will be when a player will win when the string is palindrome. What is the minimum situation for a string to be palindrome? What is the situation, right? Let's say you can rearrange a string, right? Since you can rearrange a string, let's say I give you a, then I give you b, then I give you c, right? Can this string made be a palindrome or not? Is this string a palindrome? or not? Just quickly tell me, can I rearrange it and make it as a palindrome or not? Just quickly tell me in the chat, can I make this string as palindrome or not? Can I? Can I make it as a palindrome or I cannot? Just quickly let me know in the chat. Can I make this string as a palindrome? Can I? Can I make this string as a palindrome? Can I make this particular string as a palindrome? If yes, then what will be that string? Can I make this as a string as a palindrome by rearranging? Yes, I can. How? Let's say I have this A and this A at the end, then I can have this B and this B, then this C and this C, and the odd number of A, that this A, third A, I can have it here, and this is a palindrome, right? So I will say that whichever player is getting this string, he will win, right? Right, is this much part clear to everyone? Just quickly let me know in the chat. Is this much part clear to everyone? Just quickly let me know in the chat. Is this much part clear to everyone? Right, you can make this string as a palindrome. Okay, perfect. Now let me see the next case. Now let me talk about another case. Okay, let's say I have this string. If I have this string, can I make this as palindrome or not? Just quickly let me know in the chat. Palindrome or not? Palindrome or not? I can make it as a palindrome or not? Let me know in the chat. Can I make this as a palindrome? Can I make this as a palindrome or I cannot? Just quickly let me know. I cannot, right? I cannot. Why? Cannot. Right, I can't make this as a palindrome. Right, but why? But why? I cannot make it as a palindrome. I cannot make it as a palindrome, right? But why? But why? What is the reason? What is the reason for that? What is the reason for that? Notice that in a palindrome string, there can be at most one odd character, one character with odd frequency, right? One character with odd frequency in a particular string. To rearrange it and make it as palindrome, at most if let's suppose you count the frequency, and if only at most maximum, I can see a lot of people are watching, please like the video if you haven't. Okay, so if at most, if maximum one person, if maximum one character is occurring odd number of times, then in that case I can make it as a palindrome, right? What do I mean by that? Let me make some space here, right? I cannot make that right. Let's make some space. Okay, right, perfect. So let's say if this is my string, if I have 3 A's and I have B, right? So for this I cannot make it, right? But if I have 3 A's and I have 2 B's, then I can. Why? A, then B, and then A. So this can be made as palindrome. Only one particular character is occurring odd number of times. But if there is another B, then in that case what will happen? I cannot make it as palindrome, right? For this case, if this is the case, then I cannot make it as palindrome, because if more than one characters are having frequency odd, then in that case I can never rearrange them and I can never make them as palindrome, right? Never be palindrome. Such cases can never be palindrome. Such cases can never be reversed and made as palindrome, right? Everyone will agree to this, right? Everyone would agree to this, I think, right? That is the case. And now let me say, right, now the first player is starting, right? This much part is clear. Now if the total number of total elements with odd frequency, right, if the total elements with odd frequency is lesser than equal to 1, that is if there is no elements with odd frequency, or if there is at least one element with odd frequency, then in that case, since the first player is starting, since the first player is starting, so he can make that string palindrome by rearranging it, because the frequency is frequency of number of elements which are odd, the number of characters which are odd is lesser equal to 1. So that is why the first player will win, because he will be able to rearrange it, right? So first wins. Is this much part clear to everyone? First player wins. Is this much, if this much part is clear to everyone, please write clear in the chat. Is this much part clear to everyone? No, I meant that if this is odd, right? This is odd, right? The number of A's and number of B's are odd. So how can I make this as palindrome, right? Let's say I took this case. That is A and A and B. So in this case, you can see that if only one character was odd, if A was only present odd number of times, then I could have done this. But if B is also present odd, let's say C is also present odd number of times. If more than one character is present odd number of times, then I can never make this string as palindrome. Is this much part clear to everyone? Just quickly let me know. If more than one character is present odd number of times, then I can never make it as palindrome. Is this much part clear to everyone? Just quickly let me know. Right? If more than one character is present odd number of times, then I can never make it as palindrome. And I'm saying if at only maximum one character is present odd number of times, if the frequency of only one character is present odd number of times, then in that case I will say that I can make it as palindrome. The first player will start and he can make that particular string as palindrome and he will win, right? Otherwise what will happen? Else, right? Else what will happen? Else, if the total number of elements with odd frequency, is greater than 1, so in that case answer depends on this only, right? Answer depends on this. How does the answer depend on this? Now it depends on this. Why? Because if the total number of elements are occurring in odd frequencies, then what will happen? The answer is dependent on the amount of characters with odd number of occurrences, right? If the total number of odd occurrences is even, right? If the number of odd characters that are occurring, if they are even, then in that case there will be another answer, and if it is odd, then there will be another answer. What I'm saying this, let's say A is occurring odd number of times and B is occurring odd number of times, and let's say in this case A is occurring, B is occurring, and C is occurring. So in this case you can see that only two characters are occurring odd number of times, so that is why the total characters that are occurring odd number of times are even, and the total characters like this which are occurring odd number of times is odd. So the answer will change, right? Can someone tell me what will be the answer for this? Odd number of times is okay, but in this there will be two cases, that the total number of distinct elements, like either it can happen that there can be even number of odd number elements. So here you can see 2, or you could have 4, or you can have 5. So A and B both are occurring odd number of times. Here A, B, C, let's say, are occurring odd number of times. So that in those cases the answer will change. How the answer will change? Can someone tell me in the chat? Someone could tell me in the chat, right? So I'll tell you, right? If it is odd, then I will say that player 1 wins, right? If it is odd, then player 1 wins, and if it is even, then player 2 wins, right? Why? Let me tell you. Let me just move up a little bit only. Okay, so I was telling you about this, right? Okay, let's make some space up out there. Let's say if I have a string A and I have B, right? So for this case you can see that A and B total number of characters which are odd is 2, right? Total characters are 2, total number of characters which are odd are 2, right? Let me write a more generic case. Let's say I have CC as well, right? So for this you can see that the total number of characters that are odd are A and B. A is occurring 3 times and B is occurring 1 time, right? So they are odd. But for this case what will happen? First of all, the first player comes in and he will remove this character, right? First player removes this character. Then what will happen? The second player comes in. Still it cannot be, can it be made palindrome? Can it be made palindrome? Or it cannot be? Just quickly let me know in the chat. What will you do? Will you change this, or what will happen for this case? I am claiming that if it is odd, then the first player wins, right? Is this part clear to everyone? Just quickly let me know. I'm saying what? Let's say there's one B and there's one C, right? If this is the case and there are two Ds. So in this case, you can see that there are three characters. There are three different characters, right? In this case, you can see that there are three different characters. There's this A, there's this B, and there's this three different characters which are occurring odd number of times. So you are coming into this case, right? This case is nothing but this case, right? That the number of characters, total number of distinct characters which are odd are are odd. Total A, B and C, right? A, B and C are odd. So three characters are odd. So odd may be odd aa gaya, right? That is what we are saying. So for this case, what will happen? The first player will come in and he will remove this one, right? He removes this. After that, the second player comes in and he removes this. And after that, when the first player comes in again, so is this palindrome? Yes, this is a palindrome, right? This is a palindrome. So if the total number of characters, total number of distinct characters that are odd, if the total number of distinct characters that are odd, then the player one will win. And if that is not the case, let's suppose that this was the case, A and B. So in this case, what will happen? The first player can remove, let's say this, then the second player wins, right? This is palindrome, so second will win. Is this much part clear to everyone? Second wins, right? Is this much part clear to everyone? Just quickly let me know in the chat. Is this much part clear to everyone? Just quickly let me know in the chat. Is this much part clear to everyone? Is this much part clear to everyone? Just quickly let me know in the chat. Is it? Is it? Perfect. Is it clear to everyone? Just let me know in the chat. Is this much part clear to everyone? Is it clear to everyone? Just let me know in the chat. I think that it is, right? Okay, perfect. Moving on. Let us write the code for this problem, right? What will you do? You will have, let me increase. Okay, right. So what I'll be doing is I'll be declaring, let's say, int frequency FRE, let's say f only of 26 size for all the characters, and I'll be initializing all of them to 0. After that, what I'll be doing, I'll be having a string s, and I'll be taking the string s as an input. And once I have it, so what will I do? I'll iterate through the string for I start from 0, I is less than s dot size, and I'll be doing an I plus plus. After that, what I'll do is I'll say frequency of s of I minus a small a plus plus. That simply means that I'm increasing the frequency. Then after that, what I'll be doing is I'll be also having a counter, right? I have I, let's say I have a counter is equal to 0. Counter will tell me the number of odd characters, right? So number of characters which are having odd frequencies. So if I'll start my I from 0, I will be less than 26, and I'll do an I plus plus. After that, once I've done this much part, so if my frequency of I is equal if mod 2, mod 2, if it is equal to 1, so if it is odd, so I'll count it, right? Is this much part clear to everyone? Is this much part clear to everyone? Just quickly let me know in the chat. Perfect. Right, so let us move on. Okay, what will I do next? So if it is odd, so I'll count, right? What will happen if my counter is 0, right? If my counter is 0, so in that case, what will happen? I'll say that first wins, right? First will win, right? If my counter is odd, then counter is 0, so in that case I will say that the first player will win because the string will be palindrome, right? And else if that is not the case, else if my counter mod 2 is equal 1, so if it is odd, then again, if it is odd, like let's say if it is even, right? If it is even, if the count of total number of characters that are odd is the count of all the characters which are occurring odd number of times, if it is even, then in that case I told you that the second player will win, right? Then in that case I will say that the second player wins, right? And I'll simply change the line. Else I'm saying that the first will win again, right? Because if it is present odd number of times, then the first wins. I hope that this much part is clear to all of you. Let me just compile the problem for looking if there is in case for any error. I don't think that there will be any error. Okay, so the problem is compiled. Now let me submit this problem and let us see how does this work. Okay, so it is opening meanwhile, so let me know if anyone has doubt up till now. I don't think up till now anyone has any doubt. So let me submit this and let's see what happens now. So the problem has got submitted. Let's see whether it gets accepted or not. So you can see that it got accepted, right? You can see here that the problem that I've just submitted, it got accepted. Let me show you the code part for this problem once again. So basically what I'm doing is I'm just taking this as an input, then I'm counting the frequencies, and once I've counted the frequencies, okay, so I'm just simply once I've counted the frequencies like this, I'm just checking for all the characters which are occurring odd number of times. I'm counting all the characters which are occurring odd number of times. If there is no character that is occurring odd number of times, then that means that the string is palindrome, right? That means that the string is palindrome, right? And if the number of characters that are occurring odd number of times is even, so that means that the second player will win, right? Because if after that what will happen, the first player will remove and then there will be only left one odd character, and in this way second player will win, because if there is only one odd character then the string will become palindrome, right? And if that is not the case, then the second player will lose and the first player will win. Everyone is clear with this much part? Just quickly let me know in the chat. Everyone is clear with this much part? This much part is clear to everyone? Just quickly comment down a +1 if this much part is clear to everyone, right? This part is clear to everyone? Perfect. So thank you everyone for watching. What you guys can do is coming to the last part, that is the outro. What I want to say is you can like the video if you are watching the recording, and you can share it with your friends or your colleagues, and apart from this you can subscribe the channel if you haven't already. If you haven't subscribed, you can consider subscribing the channel. And from the next week, probably Monday, next week, that is from Monday or maybe Tuesday, we'll be starting a new series that I'll be taking of CodeForces. And apart from this, another thing that I want to say is make sure to like the subscribe button and tell us in the comments how did you like this session, how much beneficial it was for you, and comment down suggestions that how can we improve and what do you expect that what we should do furthermore, so that we can build a strong coding community for all of us, right? So okay, so that is it from my side for today, and we'll see you soon in the next one, in the next live. Okay, keep coding. This is me signing off.